Greetings, everyone. Today, I want to discuss what tools and options are available from LI-COR to get fully corrected fluxes from your eddy covariance measurement system automatically and in real time. I have a brief outline of what we will cover in this webinar, but before we get started, I wanted to present a poll question to the audience to see how familiar we are with the eddy covariance method. So the first poll question is, how familiar are you with the eddy covariance method? Choice A is, I am new to the method. Choice B, I've used the method in my research. And choice C is, I consider myself an expert. I'm going to give everybody a moment to make their choices, and once everybody had a chance, we'll move on. Thanks for your responses. Regardless of our level of familiarity or expertise in the eddy covariance method, this slide represents a generalized workflow for the flux measurement. There are several steps and at each stage of the workflow, the decisions that we make affect what will be done on the next stage. For example, the design stage is a critical stage because it affects all the stages in the process. A well-designed experiment avoids many of the previously known mistakes in experiment and maintenance, but it can also recover from unforeseen or unexpected interruptions. Another big part of the experiment stages is the data processing stage. It involves several computations to precondition the data and then to account for limitations in the setup or in the instruments chosen for the measurement. Since the eddy covariance measurement generates large amounts of data, it's not at all efficient to try and perform each of these calculations by hand. Some of these calculations may be straightforward, like converting units, but the frequency response corrections, for example, could be a bit more complex, and so it's not at all efficient to try and do this for every half hour of data by hand. So at the design stage, most researchers will choose to go with one of these options. Some research groups will write their own data processing code. Maybe it's in Fortran or C++, or it's in MATLAB or another platform. The advantage here is that the program can be modified and can be tailored for the specific site. However, it requires a lot of time to understand the theory behind the eddy covariance method. And in addition to understanding the method, you also need to have some expertise and some experience programming or writing a robust processing code. In addition, if the person who wrote the program leaves, then the group there needs to figure out how the program that was written by the previous person works. So there's a steep learning curve, and a lot of effort is necessary for the next researcher to take over. The other option on the right side here is to use software programs currently available, such as EddyPro, EddyRe, TK3, and others. The benefit of using this already available programs is that there's no development time that's lost. It's already there, but you may lose some of the customizability, so you may not be able to customize it for your site. In addition, some software packages still require significant effort to learn how to use the software. So this takes us back to the workflow. Generally speaking, the data processing step is a large chunk of the effort in a typical flux measurement. So the question then becomes, what is the purpose of the experiment? And how can we achieve that purpose efficiently? So let me ask the audience, what is the purpose of your eddy covariance experiment or measurement? This poll question asks, what do you study using the eddy covariance method? Are you studying carbon cycle, or are you studying the water cycle? Or are you studying the climate change or agricultural research? Or are you focused mainly on micrometrology or turbulent transport of gases and energy? I'm going to give everyone a moment to respond to the poll. So for studies where the primary focus is not the study of turbulent transport, automating the data processing provides significant savings in time and resources. When you're not spending a whole lot of time developing processing routine or writing code to understand how the data should be processed, that's the time you can spend more in investigating the relationship between the fluxes, the ecosystem response, and the water cycle, and things like that. So far, the choices available to automate data processing fall under these two broad categories. So on the left side here, we have the data logger based programs for computing diagnostic flux estimates. These are used a fair amount, but they still require that the data go through the post-processing stage to apply the remaining corrections and get final publishable results. On the other hand, the PC-based systems require so much effort and time. Therefore, only a few research groups have implemented such a system. SmartFlux is a new product available from LI-COR that addresses the concerns we've been discussing. It provides fully corrected publishable quality fluxes in real time at your research site. SmartFlux is a small add-on module that installs inside the LI-7550 analyzer interface unit, and because it installs inside the LI-7550, it doesn't require additional enclosure. It consumes less than 2 watts, and SmartFlux uses the EddyPro processing engine to compute fluxes and apply all the corrections necessary. It uses the GPS to get absolute time information from satellites and provide clock synchronization at the site between any instruments that you have, or it provides clock synchronization from station to station that may be located in different places. So SmartFlux uses EddyPro, but some of you may not be familiar with EddyPro, so let me try to explain what EddyPro is in the next few slides. EddyPro is a free and open source software that computes fluxes and applies all corrections to get accurate final flux estimates. LI-COR introduced EddyPro as the data processing alternative in 2011. EddyPro is based on work in Europe to develop software and algorithm to standardize data processing in eddy covariance research community. So LI-COR adapted EddyPro and it made it an easy-to-use, complete data processing software. Just to give you some highlights, since LI-COR introduced EddyPro, over 2,900 scientists in over 155 countries have downloaded the software and are using it for data processing. Many researchers have used the software to get well-corrected publishable fluxes. In fact, there are over 25 citations in the literature from the last year and a half or 2 years or so in peer-reviewed literature, and that number is growing. Flux networks such as AmeriFlux in the US and ICOS in Europe are adopting EddyPro as a standard software for flux processing. Another example is the Chinese Ecological Research Network. They're using EddyPro and the SmartFlux system as their standard method of measuring evapotranspiration across the Chinese mainland. EddyPro is available for free download from LI-COR, and you can go to our website and get it from licor.com/EddyPro. So I mentioned a few things about EddyPro. I want to see if our audience is familiar with EddyPro. So I'm going to throw this poll question. And the question is, how familiar are you with EddyPro? And I'll give everyone a moment to make their choices. Thanks for the responses. So let's take a little glimpse at what data processing options exist in EddyPro. EddyPro has a lot of information on our website in terms of documentation and videos and tutorials. And there are tutorials and training that we provide on eddy covariance method in general. So if you need more information, please visit our website. Over here on this slide, what I have is some of the options in EddyPro. For example, one of the data processing steps we mentioned was the rotation. So EddyPro gives you 4 different rotation options. 2 of them are similar, the planar fit in different formulations, and the other 2 is the double and triple rotation. So EddyPro allows you to choose which method you want to use for your data processing when it comes to rotation. It also does the same thing when it comes to detrending. You have 4 options: block averaging, linear detrending, running mean, and exponential running mean. So you have this option again. You can pick which one is more appropriate or which one you're more comfortable with. Another step in the data processing is the adjusting for time lag or time delay between gas measurements and sonic measurements. EddyPro again provides you several options to choose from. So for many of the data processing steps, EddyPro gives you multiple options for each step so that you can customize the processing to your site. And here's another slide that shows more of the options available. For example, for a statistical test, you can customize how the spike count is done or how spikes are removed from your time series data. You have an option of multiple outputs. You have the option of calculating random uncertainty. You have the option of calculating a one-dimensional footprint. So these are all the options that are available in EddyPro. And this is one of the reasons EddyPro has become so much more popular, because it allows you to do many things within one software. You don't have to write a new routine to implement each one of these things. It's just a checkbox or a choice you make in the software to process your data in the first option or in the second option. So SmartFlux uses EddyPro at the site to do the computation. So since it's the EddyPro engine inside, it can do all the corrections we just talked about. This means SmartFlux applies all the necessary corrections. It brings the type of processing used to get publishable fluxes right at the station. Remember this slide? We talked about this slide. These are the steps in data processing. All of these steps are applied by SmartFlux. So we have some idea. I hope that we have some idea about what SmartFlux is capable of doing. So the next section of the presentation, I want to talk about how SmartFlux integrates into a LI-COR eddy covariance system. So here's a picture of an eddy covariance system or an eddy covariance station. The station has the high-speed gas analyzers and wind sensors, and the slow measurements, the biological and meteorological measurements, which we're going to call the biomet measurements. The central point of the system is the LI-7550. So if you have the LI-7550, SmartFlux integrates into an existing LI-7550. So you have the picture of the LI-7550 opened up here, and you can see the SmartFlux installed inside the LI-7550. Abby, there seems like there's a question from the audience. Can you please read that question?
Sure, Israel. Someone has asked, can I use SmartFlux with my LI-7500?
Thanks for the question. So the LI-75 SmartFlux works with the LI-7550, and if you have the old open path sensor from LI-COR, the LI-7500, you can get an upgrade that includes the SmartFlux. In fact, since the SmartFlux has been released, all the upgrades will include the SmartFlux unit. So if you have the old LI-7500, you can upgrade to the LI-7500A, and you get this upgrade adds the LI-7550 to your system, and it just upgrades the sensor head. So you have the same sensor head, but a new analyzer interface unit, and that will come with the SmartFlux unit. And for any new LI-7500A or LI-7200 purchases, SmartFlux is compatible right from the get-go. So I'm going to move on. So how do we install SmartFlux into the LI-7550? There are basically 3 steps. The first step is you remove the 2 screws on the left side of the cover inside the LI-7550, and then you unplug one cable that connects the power to the LI-7550, and instead place in a cable that comes with the SmartFlux unit. And after you do that, you put the SmartFlux where those two screws were on the cover. You connect the Ethernet cable, and the hardware installation part is done. And it would look something like this. You have the SmartFlux unit here. The GPS goes up on that top corner. The power connector is down here, and the Ethernet goes into one of the Ethernet ports inside the LI-7550. Once the hardware installation is done, you open up the GHG software or the LI-7500A or LI-7200 software, and you click on the button that says SmartFlux, and it will show you the unit that's connected to your system, and you choose to use that SmartFlux unit, and the software will tell you what SmartFlux unit it's connected to and it's using for data processing. So one of the questions we've had about the LI-7550 and SmartFlux is how everything comes together. What are the components in the system? We showed a picture earlier of the instruments on the tripod. This is a block diagram of where the main components are and how they interact with the LI-7550. So as you can see on this picture, the LI-7550 is the central hub of the system. So you have your high-speed sensors, the LI-7200 sensor head, the LI-7500A sensor head, or the methane analyzer, and your sonic anemometers. They all come into the LI-7550, so high-speed data is coming into the LI-7550. At the same time, the biomet data and the net radiation, for example, or soil measurements are coming through the data logger interface into the LI-7550. If you have a SmartFlux, on the right side, SmartFlux is continuously computing fluxes whenever there's a file that contains enough data to compute fluxes. And on the right top corner, you can have a cell modem that's at the site and you have access to the site from anywhere, or you can have a satellite modem and you could be sending summary or diagnostic information at a given interval, or you can have a direct connection to your laptop computer if you're at the site visiting. So once we install SmartFlux, how does the data flow in the system? What's the first step, and how does the data get collected and computed? So the next slide presents this flow in the system. So the LI-7550 is continuously collecting high-speed data and metadata with the on the USB inside the LI-7550. So that means if you have a CO2 analyzer, LI-7200 or LI-7500A, the CO2 data is being collected on the USB. At the same time, if you have the sonic installed to or connected to the LI-7550, that's also being sampled and stored with the CO2 and water vapor data in the USB. If you have a methane analyzer, that also high-speed data at 10 hertz or 20 hertz is being collected and being stored inside the LI-7550 USB. Now, the LI-7550 does not only store data, it also stores the metadata, so information about the data, so how the instruments are set up and what separation exists between the instruments and what's inside the column of data. Each column of data, is it CO2 concentration or is it temperature? It contains all that information. So the high-speed data and the metadata are stored on the USB. At the same time, the biomet data is being collected from the biomet data logger interface. So if you have soil moisture sensors, net radiation sensors, spark sensors, some slow sensors, they're all being collected by the data logger interface, and the LI-7550 communicates with the interface to grab the data every minutes or so. And then once a half hour passes where this type of data is being collected from all systems available, the LI-7550 then compresses all the files and zips them into one GHG file. So this GHG file will contain the high frequency or high speed data, the metadata about the high frequency data. It will contain the slow biomet data and also the metadata about the slow biomet data. So everything that describes the data and allows us to process it is in that GHG file. So as soon as that GHG file is created, it's shipped over to SmartFlux. SmartFlux then knows what's inside the data and how the instruments are set up, so it can start processing the data and apply all the necessary corrections that account for the site setup, that account for the nature of the data, that add any additional information or additional improvements that can be gained from the biomet data. So SmartFlux processes all the data and produces outputs. SmartFlux keeps a backup copy of the raw data in its own storage, while the LI-7550 keeps the raw data. Even though it copies it over to SmartFlux, it doesn't delete it. So it keeps a copy on the USB. You get a copy, a backup copy on the SmartFlux storage. After SmartFlux is done processing the data, it ships the results back to the LI-7550. So the LI-7550 then ends up with the raw data, the processed data, and the LI-7550 compiles a summary of the processed data. Oh, Abby, looks like we have another question from the audience. Can you read it out loud for us, please?
Sure. Someone is wondering, is data logging stopped during processing?
So the question was, does the LI-7550 stop logging data when the fluxes are being computed? That's a critical question, but the answer is no, it doesn't, because this happens. All of this happens at the same time. As data is being logged, the LI-7550, if it has enough data for half an hour, it zips it up and sends it to SmartFlux. But at the same time, it's opening up the next half-hour file and writing the data that's coming in from all the sensors into that file. So no, the data is not stopped for processing. The data logging is not stopped for processing. We continue to log data even as the files are being processed. All right, let's move on. So how do we interact with this system? We use the LI-7500 or 7500A or LI-7200 software. It's a Windows interface. This Windows interface allows us to configure the system and also look at some of the results from SmartFlux. Particularly, it contains results for up to the last 7 days from today. So if you go to the site, or if you're looking at your site remotely, you can see what happened in terms of fluxes for the last several days. And there's huge benefits to looking at this. If you were just looking at CO2 concentration or water vapor concentration or temperature or wind speeds, it may not be obvious to the untrained eye or even to the trained eye to know how they will affect the fluxes. But you can directly look at the final computed fluxes and know that if there was any issue in the final result. You don't have to wait to process the data to understand if there was an issue or not. So that's one of the benefits of looking at the data right when you connect to the instrument and it's processed and final. There are, as I mentioned, several folders or outputs from the SmartFlux and the system that are stored on the USB inside the LI-7550. So if you open up that USB, you will see 4 folders. There's the archive folder, the raw data folder, the results folder, and the summaries folder. So let's look at what each one contains. So the first one is the summaries. This is the most useful information is found in these files. There are 2 files in this folder for each day. The first one is final fluxes for each half hour of the day computed by SmartFlux, which we call the flux summaries. And the second file is an average value for each half hour of the day for all the variables measured by the gas analyzer. So if the gas analyzer, for example, is LI-7200, all the variables the gas analyzer measures and is logging, you can get an average value here. So you can use these files. Just looking at these files gives you the summary results and mean values for the different variables. And the reason we have these values or files is if you are in a remote location where you may not have the bandwidth, so the data plan to transfer all the raw data and all the results, these summarized files contain enough information to diagnose any problems or to understand what your system and ecosystem is doing. And you don't need to have a large data plan or a high bandwidth. So you can use satellite or old generation networks like 2G. They can safely transfer these files. The next folder that is inside this LI-7550 USB is the results folder. Now the results folder contains a zipped file for each half hour. That zipped file comes directly from SmartFlux. And as SmartFlux runs EddyPro, EddyPro provides outputs for each half hour that contain 3 folders: INI, log, and output. The INI folder contains the project file that was used to process the data in EddyPro. So in case you want to reprocess the data and compare what you get on your desktop to what you got out of SmartFlux, you can use this project file. The other folder is the log. This is what the EddyPro engine produces to notify any problems or errors that happen during processing. The last folder is the output. The output contains any output files requested from EddyPro. So that's what's contained inside the results folder. So EddyPro, for those who are familiar with EddyPro, there are 2 processing options. There's the express mode and the advanced mode. The express mode is essentially a predefined selection of the processing methods, and it's common to all startups. So if you if you use express mode, you use the same processing option. It's mostly okay for several sites, but it's not appropriate for all sites. So even though Express may work okay for most sites, it would be okay and even advisable to kind of customize the processing to fit your specific site. That's when we can use the advanced mode. The advanced mode allows us to choose which methods are applied, and also allows us to use more advanced methods. So how do we do advanced methods? They're basically 4 steps. We need to collect at least 1 or 2 files from the system. So we need 1 GHG file at least. And if we want to use some advanced data processing options like the planar fit and some in situ spectral corrections, we need a lot more data. So at least 3 weeks or 1 month of data for doing the more advanced options. So we take that file and we launch EddyPro. It needs to be version 5 or more or higher. And we go into the SmartFlux configuration. So what EddyPro allows us to do with version 5 or higher is configure and choose our processing options. And that will allow us to create a SmartFlux package that contains our choices on how the data is processed and how data screened. And then we upload the final stages. We upload that package to the LI-7550 via the Windows interface. And it looks something like this. You click on the SmartFlux icon on the LI-7500A or LI-7200 software, and you get 2 options, SmartFlux and processing options. So SmartFlux uses express mode by default. So if you set up and connect to a SmartFlux, immediately SmartFlux starts processing using the express option. But if you created an advanced package, you can upload the advanced file here by clicking on this button. And if for some reason you start looking at the data after you upload the advanced file and it doesn't look like it's working as well as you expected, you can just click the use express mode and it would revert back to the express mode. So these are the processing options. And so once you have this set up and it's running, then we go into how you monitor the system. The system monitoring can happen when you go to visit the site and you connect directly. to the station, and you use a laptop or you may have a computer at the site, and you plug in the Ethernet cable. The LI-COR Windows interface for the LI-7200 or LI-7500A comes up. You connect, and you can go through the steps that we've been talking about in terms of setup, configuration. The other option is to monitor the site remotely, maybe from your office or from your lab or from where you are attending a conference. For that, you would need a cell modem or some other modem to make your station accessible from elsewhere. LI-COR provides cell modems for the United States and several other countries. You can go to our website to see what's available. And we can also help you, if we don't have a modem for you, we can help you identify what should be available on and what would work with our system. I'm going to ask the audience another poll question to kind of get a feel for how many of you use modems and remote connections. And the question is, do you have remote access to monitor your site? Thank you for your response. Regardless of what method you have to monitor the site, whether you're going to the site or whether you have a cell modem, you can have the same experience using the LI-7200 and LI-7500A software. You connect to the instrument by typing an IP address, and the same configuration options are available. So you could look at fluxes that were computed for the last several days, or you can change configuration. You can look at real-time data, and you can also look at the wind distribution of the last several days. And if you need to maybe change the position of your tower or adjust the orientation of your instruments based on the history of the wind distribution, you can kind of get that information from this plot. The other thing you can do, whether you're connected directly or remotely, is to do the data transfer. The auto downloader is now integrated into the main screen, so you can click that download button and it opens up the data transfer software. This data transfer software allows you to select multiple files or just transfer a few files. And you can also set up an automated transfer. So you can tell the software to do this transfer every night at midnight or every morning. So every morning when you come to the office, you can have the last day of maybe results only, or maybe results and the raw data transferred to your computer or laptop. So this way you can monitor the system, get the data, whether you are connected directly to the station or you're connected remotely through a cell modem or a satellite modem. So in summary, data processing, as we saw, is a significant portion of the eddy covariance research, and SmartFlux, by using EddyPro, allows us to significantly minimize the effort we need to spend in data processing. And SmartFlux installs that inside the LI-7550, and it provides us fully corrected final fluxes automatically and at the site. And because it uses EddyPro, which is a software people use to get from raw data to publishable fluxes, SmartFlux allows us to get from measurement to publishable fluxes right at the site and in real time. So I want to thank you for your attention, and if you have any questions, please go ahead and submit them, and we'll try our best to answer them.
That's all the time we have for live questions. I'd like to thank Israel for the presentation, and I hope the information provided was beneficial to all the attendees. If you have any additional questions in the queue, our panelists will be sure to answer them before we close the webinar. Thank you, everyone, for attending.